Okay, great. So I'm Lauren, I'm from Trail of Bits, and today I'll be talking to you about Osquery super features. So we'll take a little bit of a break speaking about Osquery from a technical perspective and think about more from a market perspective. What can the market tell us about how to prioritize the development of Osquery? So before getting started, I'll let you know a little bit about where we're going. I always like to know where I'm gonna what I'm hearing about before I sit down and listen to a 30-minute talk. So first, I'll walk through an introduction of Trail of Bits, myself, and Osquery for both of us. Osquery super features, I'll talk about super features, what they are, how to identify them, and why they're important. Then we'll get to the meat of it, the findings. What are the 3 super features that Trail of Bits identified? And then finally, some conclusions, what we plan to do about it. And then at the end, if there's time, I can do a little bit of Q&A. We'll see how it goes. So on to Trail of Bits. Trail of Bits, you've heard about us mentioned a couple of times. We are a cybersecurity research and development company. So we do 3 different kinds of work. The first is research. This is where we build open source tools that push the science of security forward. So these are tools based often on white papers of things that could potentially be possible, and we bring them into existence. The second bucket of work that we do is security engineering. This is where we build custom security software or software that needs to be really secure for our clients. And the third bucket is assessments. This is where we look at existing software and code, we figure out if it's safe, and then we build best practices and tooling to help keep it safe in the future. So Osquery falls into the second bucket, the engineering bucket of work that we do. And we were first introduced to Osquery when in 2016, Facebook asked us to port it to Windows. We were really fascinated by Osquery. We thought it was a great tool for the security community, and so we kept going with doing development. In 2017, we rebuilt file integrity monitoring with audit-d. We added some extra Windows stuff, Windows event log support, and Firehose Kinesis support. And then this year, in 2018, we improved container introspection, and then started our Trail of Bits extension repo, which you can check out on our GitHub. And within this extension repo, we've built a couple of different extensions to do different things alongside Osquery, like our effigy extension, Google Santa integration extension, and TFS extension, which is forensic stuff, and firewall management extension. So that's how Trail of Bits came to Osquery and how we've been involved. What about me? So I'm the head of strategy and operations for Trail of Bits, which basically means I'm the resident business nerd. So I'm one of the very few employees at Trail of Bits who is not an engineer. My role at Trail of Bits and at most of the companies that I've worked at is an internal and external business analyst. So I look at Trail of Bits internally and think about what can we do from a business perspective better. And then in the external markets where we play, how do we think about like competition, new customers, things like that. My background before Trail of Bits actually was in shoe retail. So I ran a shoe retail company headquartered in Freeport, Maine, which is like right where we were across the street from LL Bean. Those were the shoes we made, and that was our slogan, and the company doesn't exist anymore, so you can take your own conclusions about why that's the case. Yeah, but after destroying the company, I went on to work as I was still in high school. I went and had a stint as like a baby web app developer doing mostly configuration and client management side of stuff. I got my MBA at NYU, and I worked, NYU. And I worked at Deloitte in their strategy and operations practice, running big tech transformations. And then for Osquery, we were doing a lot of development as a company for Osquery, but we really wanted to understand what do the users want? Like, where should this be going? And so, as was mentioned, I started building blogs based off of some user research by researching companies. Actually, I'll walk through that research next. So this is what we did when we wanted to understand what users want out of Osquery. We interviewed 5 Silicon Valley tech companies and asked them about user needs, what are your issues with Osquery, what do you wish it could do, and what do you really love about it? Additionally, we monitored Osquery GitHub issues to see sort of a wider smattering of data. We added insights from our pool of Trail of Bits clients that are a different set of companies from the initial 5 Silicon Valley tech ones. We contextualize all of our data with the technical knowledge from our own Osquery developers. And we also dogfooded Osquery by deploying it internally. Our fleet's not quite as big as most other companies. I think we're at 35 people now, but still, it helped us get some lessons on what it's like to use the software. And then finally, before releasing any of the research that we did, we made sure to gut check it against other players in the space who also have customers who use Osquery, just to make sure that our sample set was consistent with the overall population. Cool. So that's a quick intro. Now to talk about super features. So what are super features and why do they matter? So super features I'm defining as a subset of features that are representative of a fundamental expansion of a tool's utility. So you can think of it like a feature is a pair of pants, and a super feature is like Iron Man's suit, right? A pair of pants like keeps you warm, they might look really cool, but Iron Man's suit, like you can literally battle a god. So they are an order of magnitude in an increase in value over normal features, non-super features. And to define these features, we think about it in terms of 3 criteria, things that a feature must have to be considered a super feature. So criteria number 1 is that the feature must shift the product niche to an additional market segment. And I'll talk about what that means in a second. Criteria number 2, it must increase consumer surplus. Again, I'll talk about consumer surplus in a second. And then the final criteria, it must not destroy existing value for current users. So you wouldn't want to implement a super feature that does really cool stuff in a new space, but destroys 5 of the benefits that are reasons that current users use it. So you can't destroy anything. Okay, so promised definitions and explanations. Expanding a product niche. So product niche as a term comes from the idea of market segmentation. And we do this a lot in business when thinking about our customers. So you take your general market of customers and your market segment or product niche, they're the same, is the group of users and the use case that you're supporting. So for example, if retail, I like examples from retail because I come from retail. So if I'm a dress manufacturer, my product segment, my users might be women between the ages of 20 to 30, and my functional segment would be formal wear. Right. So for Osquery, I've segmented the market, and you can segment it in however is useful for whatever you're studying. I've segmented the users as being security teams and sysadmins in risk-tolerant companies versus the same groups in risk-averse companies. And then in terms of functional segments, detection is the functional segment as opposed to response and prevention, right? The classic security process. If you're going to shift a market segment and expand, you could, for example, build something into Osquery to make it less risky to use. It's more reliant, it's more performant, it doesn't have the possibility of runaway queries that lock up machines. So you do that, and potentially you can expand your user segment into risk-averse companies because they're willing to now consider the technology. So that's product niche. Consumer surplus. This one's a little simpler. This is basically just the amount that a user values the technology subtracting the price of the technology. So like the bodega down my street has a sandwich that I would pay $30 for easily. It's delicious. But luckily for me, the shop only sells it for $6. So my consumer surplus is $24. And you can think about this in a whole market perspective, like adding up the surplus of all of your users to think about what is the consumer surplus for the entire market. So what this means for a super feature in Osquery is it's not good enough to just move your market segment. Like it's not good enough to just say, now we play in this new space. You have to actually be better than the existing technology there. Or in this case of thinking about features, you have to have a good fighting chance of being better if you were to move to that segment. Fair? Okay. And then again, don't destroy value. That one's kind of self-explanatory. So why, right? This is a high bar to clear. Why do we care about super features? And the reason is, one, that it maximizes value. We're focusing on those things which have the highest utility for the overall market, for the people who are using OS Query. The second reason is it coordinates development around common goals, right? Right now, it's an open source project. It has kind of a meandering development path. This focuses our attention so we can get things done more efficiently. And then the third piece, momentum, it's really about if you select exciting features to focus on, you're going to generate momentum behind developing for these features, right? It's an open source project. Everyone has varying goals. You want to choose the exciting things that will really get people developing and working and pushing forward together. Cool, those are all the explanations. So now, on to the findings. So the first OS Query super feature that Trail of Bits identified from our user research was write access for extensions. And these are really dark slides, so I can't see you right now, but I imagine that some people might be like getting hives. Other people might be like, yeah, this is what we want. Other people are saying, what does this mean? So write extensions for extensions basically means this. OS Query Core currently has only read access to the system, and that's a good thing, right? It is, in fact, one of the reasons why companies and the management of companies feel comfortable introducing this to the system because the attack surface is really small. However, giving write access to extensions would allow extensions to do things like edit the tables that they're accessing. So for example, for a firewall extension, it would mean that you can't, it's not, you're not limited to simply viewing what the firewall settings are. You can actually change them. You can edit the addresses. So the fear about this is this, right, is hackers. This is, the people who are getting hives, this is what they're thinking about, because write access to your system from an endpoint management system is a larger attack surface. It's riskier. However, it's not as risky as you might think if you build it correctly. So the way that this would be built would be like this. OS Query Core remains to be read access only. That doesn't change. If you don't want to take any risk of having anything that has write access to your endpoints, you download OS Query Core and you don't have to expose yourself to that situation. However, if you do download an extension that has write access, you can also narrow the scope of risk by keeping its write access super narrow. So it only has write access to the table that you define. Developers of extensions with write access can keep their extensions safe by only using tables that don't allow for executable code. So for example, a firewall list of addresses is merely a list of addresses. You're not going to put some script in there and have it own your system. You can just edit and delete and add addresses. And this least privilege would be by design. So each extension having only write access to particular places shouldn't be a setting that you can switch. It simply only has access by design. You can't get access to anything else unless you're literally downloading or grabbing access to a new extension. This shifts product niche effectively from being a functional group of just detection into the functional use case of protection, because you can manage your fleet straight from the OS Query SQL interface. And in terms of increasing consumer surplus, there's definite advantages over current commercial orchestration tools. It's more convenient because you are discovering data in the same interface that you can actually do something about it right away, which is great. And secondarily, it actually can present a safer scenario than using a classic orchestration tool for a lot of these things. So you can do things like application whitelisting and enforcement, managing licensing or licenses, partition firewall settings, force password changes, revoke accounts. But you can do this with each individual extensions that have write access each to individual places. So you're not using a generalized orchestration tool that has access to everything. So actually your attack surface is more narrow. It doesn't destroy value, because even if you don't want any write access at all, you can just download core and nothing changes. And your channels, if you do download extensions, are pretty narrow for write access and attack surface. And as a bonus, we've sort of already built this. So Trail of Bits currently has a PR awaiting review where we've enabled write access for extensions. And we have actually 2 extensions that leverage this in our Trail of Bits extensions repo. That's our firewall management extension and the Google Santa integration that both use write access. So that's super feature number 1, write access to extensions. Super feature number 2, triggered response on detection. So this looks like this. This is going to look probably familiar to a lot of you because a lot of fleet management tools actually already have this sort of thing going on. So this is where Osquery looks at all of its logs. It has some kind of intelligence. It has all of the logs and then has a bunch of indicators of attack repositories that it can look at. Virus Total or some other open source thing is great. It discovers some kind of match or some kind of pattern that indicates potential attack, and then it does a thing, right? It sends out a text or it quarantines the system or sends it for more analysis. That's the triggered response on detection. This, again, would shift the market segment from being a tool used for detection into a tool used for response. So more reasons to use Osquery. And in terms of increasing consumer surplus, it has advantages among current incident response tools. So the first one is an advantage that we get to have just by using Osquery for detection, which is that it's very transparent and flexible. So we get to bring those benefits into now the response function. Also, triggers and responses can be infinitely customizable. So there's always a concern with a response program that you're going to get a bunch of false positives that generates tons of disruptive alerts or quarantines or bad things that affect performance of the overall fleet. With this kind of setup, you can customize it to be as severe or as casual as you want. So for example, you can say, upon detection of log X, query this table more often, right? Like I'm not sure if something bad's going on, but I know that I probably want more data, or I think I'm going to want more data for later. If a process from this blacklist is logged, send all of the data you're getting to Osquery into this big time analysis engine. So I want to know more about it. It's not something that I have to act on right away, but I want something to make a more a better analysis of what's happening in my system. And then for really bad stuff, if you find log Y that I know is really, really terrible and I don't care about false positives, because if it's not a false positive, like my whole company's going under, then you could do something like I want to quarantine the system and message the CISO's pager, right? And this lets companies really build their Osquery response based on the needs that are unique to their company, so they tend to be better. Doesn't destroy value. Again, if you don't want this, it would be built likely in extension. This is a feature that would make sense in an extension. So current users who don't want to use it don't have to download it. But also because of the customization, you can really make it not disruptive and light on the system. Okay. Final super feature. Technical debt overhaul. Doesn't this sound exciting? So probably not, right? This doesn't sound like a super feature off the bat because almost by definition, technical debt is the stuff that's either too boring or too much of a slog to take care of and it builds up. But it is a super feature, and here's why. So here is a pretty exhaustive list of all of the different needs and issues and new features that we heard about from those Osquery users that we interviewed. I won't run through all of them. You can actually go and look at my most recent blog post, list them extensively with a bunch of context, so it's better than reading them just off of this list. But visually speaking, it's useful because these are all the things you could fix if you tackled technical debt. These are things like performance, reliability, the stuff that makes the system as a whole better, and those are the kinds of things that users are complaining about the symptoms of, if that makes sense. So, in fact, if you tackle technical debt in your typical PM, like dump and sort, prioritize all of the stuff that's highest impact and put it in a quadrant based on how much work it takes to get done. If you go about tackling this, you suddenly start to shift the Osquery user from being only the user that exists in a slightly risk-averse organization who's okay using open source and innovative technology that might not be perfect yet, into a user group of more risk-averse companies, right? You make it more performant, you make it more reliable, you make it less likely to blow up anything, and suddenly, not only are your current users happier, but a whole new set of users that had the same complaints and therefore couldn't use the system now can use it. So consumer surplus goes up. It goes up because you make the system better for current users who are using it, and also because you get to make more users happy. And it doesn't destroy value almost by definition, again, because it's technical debt. So you're making the system better. Things should only get more good. OK, so with those three features, where to now? It's a great thing to prioritize a development path. It can really do a lot to pull everybody together and garner momentum for certain priorities that you want to tackle. But at the end of the day, it's an open source project, and it's hard to figure out how to get people to build stuff, right? Like, how do you monetize? How do you, as a company, thrive building cool stuff for a program that's basically going to be given away for free? So I'm going to talk briefly about how Trail of Bits does it. So this is how, when you've heard about, oh, we built this with Trail of Bits or Trail of Bits, but this is how we do that as a company and still keep the doors open. We have support plans. So typically our clients work with us in the long term. Clients is going to use Osquery, and they want basically a team of engineers to ensure that there's no show-stopping bugs, that when they realize they need a new feature, it just gets built. They don't want a bunch of internal distraction, and so they hire us to be that team. Additionally, we offer more rarely bespoke Osquery development, but that's mostly for the kinds of things that are either really huge, like porting to a new OS, or something like proprietary that's non-core, a hard fork. Those are less frequent, but we do those sort of more typical to classic engineering projects of a custom software. And the resources that those clients get are all these great things like private Slack channel with our engineers and bi-weekly planning meeting. They get to test the features and kind of define where the path goes. So they get all of these advantages, so all the benefits. But at the end of the day, what the community gets to benefit from is all of the things that we build for them go to everybody else. So in this way, we've been able to do a lot of cool stuff for Osquery. And for us, this is sort of the path that makes sense. So with that, again, I'm Lauren. I have like 7 minutes left, so I can take some questions if anyone has them, but I'll stop talking.